We gaze at the stars, we explore the oceans, humans are curious, we push boundaries, and sometimes we dream of having superpowers. Wouldn't it be amazing to fly like Superman or swing through the city like Spider-Man? What about having a suit like Iron Man's? These heroes captivate us. They make us believe in the impossible. But how much of their powers could exist in the real world? Let's use physics, the science of the universe, to investigate. Superman, the Man of Steel, seems to defy physics at every turn. He flies faster than a speeding bullet. He bends steel with his bare hands. He even shoots heat rays from his eyes. Flight, for Superman, might involve manipulating a field we don't fully understand. Gravity. Could he be changing his own gravitational pull? Or is he interacting with Earth's gravity in a way we haven't discovered? His strength could be explained partially by his dense molecular structure, perhaps originating from his Kryptonian biology, but even then, the force required to lift a car is immense. And heat vision? It's possible for the human body to generate heat. But concentrating it into focused beams? That seems beyond our current understanding of biology. Bitten by a radioactive spider, Peter Parker gained incredible abilities. He clings to walls. He swings through the urban jungle. And his spider sense warns him of danger. How does he stick to walls? Geckos provide a clue. They use tiny hairs on their feet to take advantage of a force called van der Waals attraction. This force exists between all molecules. Perhaps Spider-Man's mutation amplified this effect to a superhuman level. Web slinging is another matter. The strength of his webs would have to be extraordinary. We haven't created a material that strong and flexible. His spider sense, while difficult to explain, might be related to sensing minute changes in air pressure or vibrations, giving him a heightened awareness of his surroundings. Unlike Superman or Spider-Man, Iron Man's powers come from technology, not biology. Tony Stark's genius created a suit that grants him flight, superhuman strength, and an array of weapons. The suit's power source is a major hurdle. Current battery technology couldn't sustain the kind of energy output Iron Man uses. He'd need a source far more powerful and compact, perhaps something along the lines of a miniature fusion reactor. The suit's material is another challenge. It needs to be incredibly strong and lightweight to allow for flight and combat. While we've made strides in material science, we're nowhere near creating an alloy that meets those demands. Many superheroes defy gravity. Superman flies effortlessly. Spider-Man swings with impossible agility. Iron Man soars through the sky. But real-world physics tells a different story. Flight requires overcoming gravity, which is a constant force pulling us down. We've achieved flight with airplanes and helicopters, but they rely on lift generated by airfoils and rotors. Superheroes don't have these. They seem to ignore gravity. To achieve true superhero flight, we'd need to discover new physics, perhaps a way to manipulate gravity itself. Energy, the real Achilles heel of superheroes? Superheroes expend incredible amounts of energy. Superman can lift enormous objects. Iron Man's suit requires massive power. So, where does it all come from? The human body, even Superman's, gets its energy from food. To fuel his feats of strength, he'd need to consume a staggering amount of calories, far beyond what's humanly possible. Iron Man's suit would require an even more potent energy source. Current battery technology simply isn't up to the task. Material science, from Kryptonian skin to Iron Man's armor. Superheroes often possess incredible durability. Superman is bulletproof. Iron Man's suit withstands extreme temperatures and impacts. Can real-world materials compare? We've developed bulletproof vests, but they're bulky and offer limited protection. Superman's skin would need to be many times stronger than any known material. Iron Man's suit would require an alloy that's both lightweight and incredibly resilient. While we've made progress in materials science, we're a long way from replicating superhero-level protection. The real-world science inspired by superheroes. While superhero powers might seem impossible, they inspire us to push the boundaries of science. The desire to fly like Superman has driven aerospace innovation. The dream of super strength fuels research into exoskeletons and advanced materials. Superheroes, in a way, set goals for science. They give us something to strive for, even if it seems out of reach. And who knows, what seems impossible today might become the reality of tomorrow. The enduring appeal of superheroes and science. Superheroes with their impossible powers capture our imaginations. They embody our desire to transcend limitations and make the world a better place. While their abilities might defy the laws of physics as we know them, they remind us of the power of imagination and the importance of scientific curiosity. The pursuit of understanding the universe, even in its fictional forms, drives us to learn, explore, and innovate. So the next time you see a superhero defying gravity or bending steel, ask yourself, what scientific breakthroughs would it take to make that a reality?